Okay, thanks,
Okay,
Martin.
storage on there now.
Thanks very much. Hi all. So my name's Tom Rafter. I'm the solar PV product manager for Bauder. And as you're aware, I'm going to be talking to you today about solar. Um, the idea behind today is to give you an overview of applying solar to flat roofs. So I'm not going to spend too much time getting into things like photons and electrons. We're not going to get into the sort of detailed electrical side. It's more about, as part of the design team, how you apply solar to flat roofs, what you need to consider, the drivers, why we're doing more solar on our rooftops. And then we'll look into more detail at applying green roofs and solar together. And then finally, we'll finish up with a bit of a discussion around the sort of fire standards and where we're at the moment with applying solar to flat roofs and green roofs. And I've left that bit very much to the end because I think that's where all the discussion will be and where the questions will be. So um, when we're talking about solar, we're talking about when we're talking about photovoltaic, we're talking about solar PV, it's often called. It's electrical energy from sunlight. We're not today talking about solar thermal and heating systems. The reason solar PV has really taken a march as far as renewable technologies on our building is concerned, really, is because it's easy to design and install, which is why we are here as roofers and we can, we can deliver it. It's scalable. So whether you have one panel or 5 panels on a roof or 5,000 panels on a roof, the technology is not really very different. It's easy to maintain, it's easy to install, it's easy to work out the return on investments. So for all of those reasons, solar PV has become a really important part of our building design and what we apply to our buildings, particularly as the decarbonisation agenda becomes much more important, as it should. There's not a lot to a solar PV system. I mentioned a moment ago that it's become an important part of what we do because it's simple. There's not a lot of parts. So we have a solar panel, your collector, if you like. You've all seen these before, I'm sure, on some kind of mounting system that attaches it to the roof. We have DC cables coming in via an inverter. So the inverter is the brains of the system. It switches the energy from DC to AC, so it can be used in our buildings. It manages the energy load. It does the fire management. So the inverter really is an important part of the system. And then we've got an AC cable or cables into a fuse board. Now it says their main fuse board. It might be the main fuse board. It might not be. It really does depend on the building type, where the distribution boards are. If you're working on commercial buildings, that may well be a connection at plant room level or rooftop. It depends on the size of the system. If it's a particularly large system, then it may well be back to the main fuse board, but it can be flexible. And then we're back to the mains. So as I said, there's not a great deal to it. Simple systems. And what's driving them? Well, I'm not going to get on my soapbox too much tonight, but we have a climate crisis on our hands. We have to do something about it. We need to decarbonize our grid, electrical grid, and solar PV is a small but important part of that. It's not a silver bullet. It's not going to fix all our woes, but it's a really important way of helping to decarbonize our buildings, and it's a really good tool. Historically, I would very much, the driver behind solar has very much been that decarbonisation agenda, and we have things like NZEB coming into play now, which will drive the specification on new builds. And I guess, sorry, one of the things I should have said at the start of this seminar is I am, so I'm obviously UK based. We do a lot of work in Ireland. A lot of what I'm talking about today will span both the Irish markets and the UK markets. As I understand it, a lot of you will work on projects in the UK as well. So, but NZEB will drive specifications on new builds. What's changed over the last 12 months is the energy prices, and we all know what's happened with energy prices throughout Europe and why it's happened. But if I was doing this seminar to you 12 months ago, I would have been talking about the decarbonisation agenda and how you can save money by decarbonising, win-win. That conversation is very much flipped on its head now. And actually, many of the projects that we're working on, there may be drivers for NZEB or BREEAM or local planning conditions, but largely from a client perspective, solar PV pays for itself. We've got UK-based clients that were paying 9 pence per kilowatt hour in 2019, 22 and a half pence per kilowatt hour for their electricity in at the start of last year, and they're now paying, or they're now being advised that they'll be paying upwards of 60 pence per kilowatt hour when the price cap ends in April. So it's not an exaggeration to say that prices have gone through the roof, and they're not likely to come down. If they do come down at all, they won't come down very far. And that has meant that solar PV systems are paying for themselves, and paying for themselves very, very quickly. Solar PV system, if you install a solar PV system on your house or your office building, ultimately you pay for the system to go on the roof, and then the energy that provides you get for free, or you're not buying it from the grid, and that's how you make your saving. You can sell your electricity back to the grid, but the return on investment is really made. You'll get significantly less what you sell back to the grid than what you're saving by that you can use on site, self-consumption. So we look for sites when we're designing solar PV systems, and the best return on investment is always where you can use as much energy on site as possible. Now, if you're looking at schools, offices, libraries, factories, any buildings that have a relatively high base load and are occupied during the day, solar PV will make absolute sense from my financial perspective. It's slightly different for domestic because it does depend on when and how the occupier uses their electricity. It's much harder to predict and project how those occupiers are going to use the electricity, but it still does make sense. I mean, generally, when we do our calculations, we might at the moment be looking at 3 to 5 years for a commercial application. Very often it is 3 years now, whereas you'd be looking at maybe 7 years for a domestic, because that self-consumption is largely less. But battery technology is coming down the line, getting better and cheaper all the time. The management systems, so diverters, so that electricity goes into your hot water tank or charges your electric vehicle. The technology is there now, so the self-consumption is pushing up all the time. But as I said, the best return on investment is where you can use the energy on site. And a quick case study, this was a project we actually did 3 years ago now, I believe. They are, as of last year, paying 34 pence per kilowatt hour for their electricity. That system would pay for itself within 4 years, saving in year £40,000. That would have cost about £130,000 at the time of installation. And what we see here is the energy consumption of this was a primary school in Suffolk in the UK that we installed many, many years ago now, but it gives you a really good idea of the kind of energy profile that a school will have. So 7 in the morning here, 7:30 at night, and your solar PV system will be producing when they're using their electricity. And for the return on investment side of things, that's really what we're looking for.